Hey guys, today I want to go over the notes for water pollution, and this is a long one, so bear with me here. As always, you can follow along here with the guided notes that came in the packet, and the PowerPoint will be here. So, we have water pollution as any chemical, biological, or physical change in the water quality that has a harmful effect on living organisms or makes water unsuitable for desired uses. You can fill this in here, and I'm going to move my face out of the way as we move through the guided notes here. And a couple that you're going to put into this, we have disease-causing agents, which include bacteria, viruses, protozoans, and parasites. Oxygen-demanding waste, which are organic waste that can be decomposed by aerobic bacteria, and we'll talk about this kind of thing in just a minute here. We have water-soluble inorganic chemicals, soluble meaning that it can dissolve in water, insoluble being the opposite of that, meaning that it doesn't dissolve in water. And then we have organic chemicals, things like oil, gasoline, plastics, pesticides, cleaning solvents, detergents, etc. We're going to keep going here. Sediment, which is suspended matter, insoluble particles of soil and other solids, and this is the biggest class of pollution by weight. There are other types of pollution that we'll go through that constitute more, but sediment is one of the bigger problems by weight. We have water-soluble radioactive isotopes. These are just ionizing radiation sources, nuclear fallout, things from power plants, sources like that. We have genetic pollution, which is the introduction of non-native species, and we'll talk more about invasive species and non-native species later on when we get to the ecology unit, but just know that that's a source of water pollution as well. And thermal pollution, which is heat added to water. I'll give you some examples of this in class, but know that marine life is very sensitive to temperature and pH changes. Okay, so we're at this dissolved oxygen portion now. The oxygen-demanding waste. Large populations of bacteria that decompose in these waters can often degrade the water quality by using up all the available oxygen that's there for them. So dissolved oxygen is always a key indicator of water quality, and you can see what determines good water quality here. And this dissolved oxygen level can be measured scientifically. So the biological oxygen demand is oxygen that is removed from water when organic matter is consumed by bacteria. So that demand means that for all of the organisms living in there, this is the amount of oxygen required. And if the bacteria outnumber other marine species, then they're going to use all of that available oxygen and not leave some for the other marine life, causing them to die off. So low oxygen conditions may kill fish and other organisms. And sources of organic matter include natural inputs, which are bogs, swamps, leaf falls, and vegetation that align waterways. You have human inputs, which are pulp and paper mills, meat packaging, any kind of manufacturing process that puts waste into a water system, and then non-point inputs. And we'll talk more about non-point and point source for pollution here in just a second. And this is runoff from the urban areas and agriculture areas. So all streams have some capability to degrade organic waste, but the problems occur when the stream is overloaded with biochemical oxygen-demanding waste, which can cause that those oxygen-hungry bacteria, those aerobic bacteria, to increase in number. Let's go over a couple terms here. We have degradable. That means that it can be chemically decomposed. Okay, we have photodegradable, which puts the prefix photo in front of degradable. So we already know that degradable means to be able to break down chemically. Photo means light, so this means that it can be broken down by light. And then bio, you should all know, means life, and so it means living organisms are capable of decomposing or breaking down this substance. All right, so one of the big factors, or one of the big things in pollution, in the pollution section, is point source and non-point source pollutions. And it is easier to control a pollution that comes from a distinct source because that source can be identified. We call this source a point source, and these are discharge pollutants at a specific location through pipes, ditches, sewers, things like that, where it can be easily identified where it comes from. If you don't know what the word discharge means, it just means the output of something. So if you're discharged from a hospital, you are pushed out of the hospital, you are released from the hospital. So when we talk about discharge of a waste, it means waste is put out of something. And then non-point source pollution is the opposite of point source, and that means it cannot be traced to a single site of discharge. So these are substances picked up and run off and run into an area where we can't necessarily discern where that point source or that pollution type came from. Non-point source water pollution from agriculture is the largest source of water pollution in the U.S. at about 64% infecting streams and 57% of pollutants entering lakes. That obviously goes here. The notes here are a little bit mixed up. The oxygen demanding waste is what we went over just a second ago here. And then non-point source and point source obviously go here, and you can fill that in here. All right, so we're going to get to diseases now, and these have a little bit more of a graphic nature, so if you have a weak stomach, I suggest you not look at the pictures here. Just follow along with what you can see. You can read this on your own, pause the video if you'd like. We'll talk more about biological magnification. Just write it down in this point. At this time, we won't talk too much about it. Just know that it's something that exists and causes potential problems later on in a tertiary or in a trophic level. Okay, so diseases. These are pathogens that can be carried on through water, and you can see these here when we talk about each one. So, waterborne bacterium. Disease symptoms usually are explosive emissions from either end of the digestive tract, and these are things like E. coli. We have waterborne protozoans, and these are disease symptoms that are usually explosive from both sides. So this is, a common trend in waterborne illnesses. They usually lead to severe stomach problems, including dysentery. Here are some waterborne human viruses, so things like hepatitis, the norovirus, and the rotavirus. Here we go with the guinea worm disease, and you can read more about it here. Guinea worm has almost been eradicated to this point. You can read some of the facts here. It is a very nasty disease that infects parts of Africa, but it has almost been eradicated in the world. You can see some of the graphic pictures here and read what guinea worm does. And there is no vaccine for guinea worm, but we have been successful in treating the source of that organism. So now we're getting down into heavy metals. And you can read that here. Heavy metallic elements have a density of greater than 5 grams per cubic centimeter. They are water soluble, readily absorbed into plant or animal tissues, and they combine with biomolecules, which can be potentially dangerous. So some sources of heavy metals, these are natural, can be redistributed by geologic and biological cycles. We have industrial, maybe the burning of fossil fuels, and then environmental pollution. And these are some of the heavy metals you see here and where they come from. So getting into some nutrient pollutions here. These are phosphorus and nitrogen are the major concerns of these nutrient pollutions. And some of the sources here are animals, are humans, and industrial waste, excuse me, stormwater, erosion, and excessive use of fertilizers for crops and things like that. And these can lead to a whole source of problems. Okay, we call this one of the big problems here eutrophication, and that's the natural nutrient enrichment of lake. And these can cause huge problems in the result of algae blooms. So high nutrient concentrations can cause eutrophication, which is essentially means well-fed in Greek, of water bodies. Eutrophication is characterized by rapid increase in plant life. You can see how this lake is kind of green here. See how the water is green when it should be normally a bluish color. An example is the algae bloom shown. Algae bloom blocks sunlight, so it causes plants below to die, and since these plants aren't producing oxygen that dissolves into the water, it can also kill other marine organisms like fish. You can read this here. And you can see all the eutrophications here. So due to some of the agricultural runoff in the Mississippi River, it has caused this in the Gulf of Mexico. You see all the eutrophication, all these green areas where the water should be this nice bluish color. All right, so erosion is the number one source of water pollution. We already talked about that by weight. And this is bare soil that easily washes into storm drains. You can see how the water is murky and muddy here. That can cause the same effect as eutrophication, not necessarily the plant growth, but blocking sunlight below, which increases or decreases the amount of dissolved oxygen due to marine plants dying underneath. And you can see the effects of sediment unloading here. and write those down. All right, we're getting into pH here. Okay, generally the young of most species are more sensitive to pH and environmental conditions, and that goes for humans as well. Generally, you see diseases affecting the young versus the old more so than they would just a healthy adult, and that goes for most other organisms as well. Young and very old of these species are more affected than middle, but you can see how pH or the acidity or basicity of something can affect how it lives. You can read that there. Thermal pollution occurs when water is withdrawn, used for cooling purposes, and then that heated water is released back into the original environment. And I already talked about how how marine organisms are very sensitive to heat and increases in temperatures or decreases in temperatures. Talk a little bit about invasive species here. One of the major concerns that I want you to realize, other than just writing down the guided notes here and going through that, is that invasive species cause problems in the fact that they have no natural predators in the environment that they're introduced to. And this can cause an overgrowth of that species that was invasive, and in turn cause them to use most of the natural resources that were available in that area. Okay. Lastly, in the guided notes here, we want to go through groundwater pollution, and this is where we pollute the water that is beneath the surface in the water table and aquifers in that area. This is extremely difficult to clean up, and pumping groundwater to the surface to purify it is very costly. And this is what most of the water that you use comes from. If you have a well, if you live out past the city limits, chances are you get your water from a well, and this pollution will affect that type of groundwater and render your well useless. You see some more here. And there are ways to prevent the contamination of groundwater that include reducing the source of water pollution in general. And it all goes with generally monitoring these pollution sources. So how do we deal with water pollution? A lot of it came from the Clean Water Act and the Water Quality Act. And these are legislation passed by the United States government that regulates what gets put into our water, and when somebody pollutes a source of water, how that is managed due to cleanup. Okay, septic tank systems are regulated, and treatment facilities. You can see more of that here as I just slapped through the PowerPoint. Coastal waters can also become affected in these. So these are especially highly affected by pollutants because they are heavily used. They are closed to sources of pollutions. They are generally shallow water bodies because they're coastal. You have low-lying plains above sea level. And coastal pollution is made up of ocean pollution and ocean debris and can affect those coastal environments. So the main types of ocean pollution are oil, sewage sludge, and chemicals. Mercury is one of the big ones, and you'll hear about that if you eat a lot of tuna. You can see oil spills here, and these are caused by tanker accidents, intentional dumping, drilling or pumping errors. And the effects of oil spills are very dangerous. I'm sure you've all heard about them to this point, but you can read these here. One of the major oil spills in U.S. history was the Exxon Valdez spill in 1989, and you can read that here off the coast of Alaska. In actuality, that was only number 53 on the list, and this is an old list, and so the BP oil spill a few years back isn't on here. DDT was a widely used pesticide that's now outlawed for agricultural purposes, but it was very dangerous, used to kill off mosquitoes and other organisms like that. PCBs are industrial chemicals, things like coolants and things like that.